Hey, we've got a new piece of equipment on the bench here. It is a cable length checker made by a company called Soar, and it's the 1500. I got it for about $10, and it's even got the plastic still on it. This thing is an old bit of kit, and it has a problem which we're going to try and fix. But yeah, it's like someone hasn't taken the plastic off. So yeah, let's do that now. Oh, come on. Oh yeah. Oops, a bit sticky. Yeah, a little bit more up there. Come on, you. Nearly got it. There we go. I'll give that a bit of a clean up with some alcohol later. But that is basically for checking cable length. If you imagine you've got, say, for example, you've got two buildings and there's a wire going between the two buildings, like a Cat5 or an Ethernet cable or something, and there's a break in that cable. You got to find out where the cable is so you know where to dig to do a repair or whatever. So what you do is you hook up something like this to the end of that wire, one end of it, and then this will actually send a pulse from its pulse output. Output is two words there, and it will then that pulse will then travel down the wire. It will hit the end or the break, whatever, and it will bounce back, kind of like ripples in a pond. If you throw a stone into a pond, the ripples will come out. They'll hit the edge of the pond or something in the water, and they'll bounce back. This measures that reflection. It then does a little bit of a calculation with what's called the NVP, or nominal velocity of propagation, and that will then let it determine what the length of the cable is. The NVP, or nominal velocity of propagation, is it's a specification on the cables. So like if you buy a Cat5 cable or a Cat6 cable of certain like characteristics, you look in the data sheet, and often it will tell you what that is. If you don't know what it is, you can actually use a known length, like say 100 meter, or you get your, what's it, 300 foot or 305 foot. Is it 300? No, sorry. 1,000 foot or 305 meter, they're about the same. A roll of Cat5, you hook it up to this, and you know what the length is, so then you can adjust this until you get the right length. That gives you your NVP. Then you can go and test it on the actual wire underground or wherever it is. So you can kind of work backwards and sort of calibrate this unit to get that number, so then you can go and test it on the real thing. This has a few settings on the front. You can see here we've got the power, which obviously turns the unit on and off. We've got feet and meters, which is for, well, changing the display from feet or meters if you're American or you're not American or British or Australian or whatever you want to be. You can swap that back and forth. And then we've got long and short. The short is for meters from 5 meters to 200 meters, and the long is from 200 meters to 2,000 meters. So that'll be like, you know, changing the pulse, maybe the strength of the pulse or the width of the pulse. They'll be changing some characteristics there to give more optimum results on those two different ranges. So I've already had a bit of a sneaky peek inside this, and I know that there's a problem. It had some NiCad batteries, and they have since been removed, but their presence has been made known, as NiCads are wont to do. So we'll open this thing up, see what's going on. We'll try and repair it, because I wouldn't mind getting this thing working, because it could be a is that coming out? It could be a nice little bit of kit just to keep on the bench. There we go. Now if you look over here, we got a bit of something going on, some blur. What's happened is the batteries sit inside this case. Someone's actually peeled the label off the battery and stuck it in there, which is nice. Whoever removed the batteries back in the past. So that means I can easily match up a new battery. But the battery pack would have sat in that carrier there, and then the wires come over. But the goop from inside the batteries has like wicked along the wires onto the circuit board and done a little bit of damage. It's not too much. Definitely repairable, I think. but we're going to have to desolder a few bits and pieces, the fuse holder there and these resistors and the old bits of wire, clean that up, but the rest of it looks pretty clean. Looks like we've got a power transistor. That might be for the voltage regulator. What is it? Yeah, it's a 7805. So that's a 5 volt voltage regulator. Smoothing cap there, 1000 microfarad. Looks like we've got a little boost converter. I'm not sure exactly. There's ground and plus in, and then we've got V4 and V3 out with a negative. So positive, negative, G. I'm not sure. It's a voltage converter of some description sitting there. We've got this metal can that'll be doing something maybe with a pulse detection or pulse generation. Got that shielded to keep noise out. Screen is behind there, just a standard little LCD, maybe a 4-digit display, and we've got the little dials there on the front, up and down. You can buy this sort of thing on eBay, these sort of little modules, and often they'll all clip together, so you can just clip together as many as you need. Good for making little decade resistance boxes and stuff. The rest of it all looks like it's 7400 series logic. We've got some Texas Instruments, Oki brand, Japanese brand there. Motorola up here. It's all pretty solid state. There's not much else going on. There's no microprocessor or anything in there, so it's all just programmed with solder, basically. So what I'm going to do, I'm going to pull this out and start having a look at that. We'll get a bit of a closer look at this area here where the battery's done some damage, and see what we can figure out with fixing that up. Alright, so I've removed the parts here. I couldn't take the front panel off because it looks like I've got to peel off the front labeling here to get to the screws to remove the BNC to then take the front panel off, so I'm just going to leave that on there. I might actually put a bit of tape just on this end so this doesn't flap around in the breeze, just like that, and that'll just help to support that there. So I've removed all the 2 resistors and the fuse. I took a photo of this too because the fuses are actually different values. The 7.5 ohm is R30 towards the front, and the 30 ohm is the R31 towards the back. So I've got that desoldered. You can see the extent of the damage. It's not too bad, just this little area here, but we'll definitely clean that up, open it up, and get in there and get rid of anything that's going to cause problems. And it looks like someone's actually had a bit of a go at repairing this in the past. There's a broken trace there, might have been burnt out, and I actually found a bit of wire was soldered across there. So maybe when the battery died, it's done something to the circuit there, because that's where the batteries come in. Also, it looks like there's been some bits replaced. You can see these 2 here, and some other stuff. This one over here as well. And on the front panel here, the switches and that. So it looks like maybe they've desoldered the front panel, take it off or something. They've replaced a few chips around the place. These here, I can get the light right. You can see there, they've got a bit of flux there, been soldered. That's this can. So I'm not sure what's going on there. But we'll fix this first. Then we'll fire it up and see if it works. And if we need to, do some further repairs. Alright, so I've taken off the old solder mask all around here. Gave that a bit of a treatment with some 5% acetic acid, otherwise known as white vinegar. Distilled water, gave it white with isopropyl alcohol and a bit of a scrape. This area here, there's no copper left. It was all green. Like it's turned to copper oxide, I guess. Something is, yeah, there was nothing left. That's bare circuit board underneath. But that's no worries, because this is just the ground plane. This trace here, this is the positive, and also it goes underneath to the fuse here, but that's the one that was broken underneath, so we'll put a new bit of wire on there on the other side to repair that trace. So I'll put some lacquer on here, and that'll make that all good again. I've given a bit of a polish as well with the fiberglass pen, just to make it as shiny as I could, get rid of as much of the goop. So that should be okay now. So I think if I put these components back in, the fuse and the 2 resistors, we might better fire it up, because the jack there, that's the input jack, 12 volts, and it's a center negative, which is a pain. Grrr. No center negatives. But there is a reason for it. It's because the outside contact is actually switched. This is a 3-terminal device. The center terminal goes straight through. We got an outside terminal, and then we got a switch terminal, kind of like when you plug your headphone jack in it. They often have a switch terminal. The reason they do that is so that when you plug it in, it switches the battery off, and this will charge the battery, but it will use the external power. Whereas when you unplug it, the switch contact inside will close, and it will allow the battery power to power the circuit. So let's hook some power up. I'll replace these. I'll put these back in. Sorry, and we'll hook the power up and see if we get anything happening on the front screen. And if we do, well, we can start testing it with a roll of Cat5 I've got sitting here. Okay, so I got the board repaired. I gave it a bit of clear fingernail polish on there just to seal it up. I don't actually have any lacquer spray, but this is just as good, and means I can get in there without spraying half the board. So I keep some of this around, not for my fingernails, but I got some red stuff as well. But I use it mainly for this sort of a thing. When you set a trim pot, put a blob of it on top, and it'll hold the trim pot from being tampered with or vibrating and moving around the place. But the clear stuff is good just for a bit of lacquer on the board there. And I also put that little jumper back in while the repair. So we are ready to turn it on. I've got my wire plugged in here. Center negative. And if I hit the power button, what's going to happen? Oh, it's working. Nice. It says open. So it looks like it tells you if it's open circuit or short circuit. So I've got a BNC cable here with some jacks on it. Some alligator clips, sorry. So if I plug that in, and if I short that, we should see that change. Yep, there you go. Short. Open. Awesome. So that's working. This isn't going to work on this cable because it's so short, but I'll go and grab my actually it's Cat6. I said Cat5 before. I got some Cat6, a whole roll of it. Hook it up and see what it says. I thought I'd better put the case on before we go testing, just so that we don't bump anything or knock anything around that's too critical. So I'll hook up the power with my completely not dodgy power connection there. I'll stand that up just so we can see what's going on. And if we turn that on, we have got power. Open circuit, 0, everything. I've got my category 6 cable here, or category 6A, because it's shielded. And I've twisted the shield, and I've got one pair, just a blue-white pair, twisted together there. So that's what we're going to test between. Now I know this is about 941 feet. I've used a little bit, but I don't know what the NVP is, the nominal velocity of propagation. So if I was to need to test some of this cable, because I've got this cable all through my house, what I can do is I can hook it up to this. I can calculate the nominal velocity of propagation as I explained before, using the known length. Then I can transfer that to the wire that I need to test with the same number in here, and it will then tell me the correct length. So let's hook this up and see what it tells us. So it's saying 426 feet. 941 is the number. So let's go up. 5, 6, 7, 8. That's 1,900 and about 1,000 feet. So we got to come down a little bit. 920, 930, 943. That's pretty close. I can't go a decimal point. So it's either going to be a little bit short or a little bit long. So basically the NVP of my cable is between 82 and 83 units of velocity of propagation. I'm not sure what the units are, but it's yeah, the number is between 82 and 83, or I think it's actually is it 0.82 units? Who knows? So that's actually working. So then what will happen is I then disconnect it from there. I leave that number on in the dial, and I can go and hook it up to something else, and then it will tell me if it's going to behave. There we go, what the length is. That's interesting. If I hook it up backwards, so the shield is to the center, it doesn't work. So at the moment it's hooked up so that the center of our coax is going to the shield of the Cat5 cable, or Cat5, Cat6A. So it's got to be shield to shield and center to center. Then it works. Ah, interesting. I also did hook this thing up to my scope, and on the screen now I'll put the picture of the scope up. You can see the pulse there that it sends down the line. Now, unfortunately, no matter how I tried, I couldn't get an image of the reflection pulse. If I set the scope lead to or the scope probe to 1x mode, the scope itself was putting too much load, and this thing would then not read the length of the cable, but the length of the scope lead going between this unit and my scope. And I couldn't see a pulse. If I set it to 10 times, where it wouldn't, the scope then wouldn't interfere with the measurement, being 10 times, I couldn't actually see the pulse because it was attenuated too much. So unfortunately, with the scope I've got here, I couldn't actually measure the pulse return. But as you can see there is a pulse being sent out, and as you can see on the screen here, it is actually working. So we've got a working unit. It seems to be doing what it's supposed to do. Next step, getting some batteries for it. Another trip to Akihabara, and I've got some new batteries and a connector. I was going to use AA batteries and use 12 of them, so I have 6 for 7.2 volts because we need 7.2 volts, and then another 6 at 7.2 volts, and they'll be 1000 milliamp hour because the AA batteries are 1000 milliamp hour. So put those two together and you get 7.2 volts at 2000 milliamp hour, but it won't fit. It's a few millimeters too small in the different directions, and I couldn't actually make them fit in there. So I was bumbling around the shop looking at different types of batteries, and it turns out that these will fit. These are a NiCad SC for sub-C, 2100 milliamp hour. So there's slightly more capacity than what the old battery was. I guess that's the progress of technology. But these will fit. So they will sit in here, kind of like that. A little bit smaller, but that's fine. A little bit of wiggle room, that's cool. And I'll solder those together so they'll all be in series. That will give me 7.2 volts at 2100 milliamp hour, and I'll heat shrink those into a battery pack, and then that can be double-sided sticky tape down. And I've got this connector here. So it's just a connector with the crimp pins that fit together, and that will then allow me to wire into the board, but not permanently. Also, I'm not going to wire directly into the board to try and avoid what's happened here before. It seems like the whatever has come out of these batteries has wicked through the wire and then deposit itself on the board. I'm hoping with connectors, they'll act as a bit of a dam, like a stop, so that if it wicks through, it'll stop at the connector and won't continue through if they leak again in the future. Also, it makes it easy just to disconnect it and reconnect it if I need to for whatever purpose. Battery is done. Heat shrinked, nicely labelled, double-sided taped in there to keep it secure. Plug is plugging, and it's all connected into the circuit board there. So does it work? Yes, it does. Thumbs up. Working perfectly. No wires to be seen anywhere. So all that needs now is for the enclosure to be installed. Enclosure to be enclosed. And then, if I can get it together, put the feet in. We'll give those a bit of a tweak with the screwdriver. Last one. We are done. Look at that. Nice. We can bring the bale around to angle it up at a convenient angle. Finished. Alrighty. Still working? Still working. we are completely finished and done. That's the end of this video. So don't forget, if you feel like it, hit that subscribe button. Keep watching the videos. We'll see you in the next one.